Okay, so for this foldable, all you need is a sheet of paper, a pen, and some scissors. This one's going to be pretty easy to make. You're going to take your piece of paper and fold it down to a triangle. We're trying to make it so it's a square piece of paper. So you've got your paper folded into a triangle, and we're going to cut off this bottom piece down here so that our paper is square. Okay, so now we have a square piece of paper. You can get rid of this. We don't need that anymore. And I'm going to go ahead and have you fold the other corners together so we can find the center of our square sheet of paper. Okay. And then when you open it back up, you should have an X through your paper. And I'm going to go pretty quickly through the rest of this on how to fill this out. But remember, you can always press pause if you need more time to copy things down. So I'm going to take each corner and fold each corner into the center. This is called an envelope fold. So each corner is going to be folded into the center. And you're going to want to leave everything closed except where you're writing when you start filling it out. Okay? So on one of these triangle pieces, you're going to label it 1 and call it set notation. Then on another corner, or another triangle piece, you're going to call it absolute value. Then on the another triangle, you're going to label this one evaluate expressions. And then on the last triangle, we're going to call this distributive property and combining like terms. Okay, so you should have set notation on triangle 1, absolute value on triangle 2, evaluate expressions on triangle 3, and distributive property and combining like terms on triangle 4. Now I'm going to show you what I want you to put in them. So on your set notation triangle, I want you to lift that up, and here's how you're going to fill it out. So lift up your set notation flap, and on the top I want you to write these 3 definitions: null set, subset, and element. And they're the definitions. Remember, you can pause this if you need more time to write them down. And then I want you to fill out the examples. So there's 2 examples here. The first example wants you to list the even integers between -4 and 12 in set notation. The dark purple is the answer. Question 2 wants you to put those numbers in order. And again, the dark purple is the answer. Then on your flap that's titled absolute value, I want you to write the definition of absolute value, which is the distance a number is from 0. And the answer to finding the absolute value is always positive. And then there's 3 examples here for you. The first example wants you to find the absolute value of 47/10, which is 47/10. The second one wants you to find the absolute value of -47/10, which is, again, 47/10. And then the third one wants you to find the negative absolute value of -47/10. So you leave that negative sign on the outside. You find the absolute value of -47/10, which is 47/10, and then you multiply by that negative. So the answer to number 3 is actually a -47/10 because that negative sign's on the outside. Okay? Then on number 3, evaluate expressions. I want you to write the order of operations, And then your hint on this one is to keep track of negative signs. And to do that, you're going to use parentheses when plugging in a number for a variable. So here are the examples. There's four examples. Number 1 says, if m equals negative 3.1, what is the value of negative m? So I plug in negative 3.1 for m, but I leave that negative sign on the outside. My answer becomes 3.1. Number 2, if y equals 4.93, what's the value of negative y? Again, I use parentheses to plug in my value, and that negative times 4.93 is a negative 4.93. On number 3, I multiply first, so I do 2 times 8, which is 16, and then I subtract 16 from 14, which is a negative 2. And on number 4, I do 2 times negative 8, which is a negative 16. But don't forget about that minus sign. So minus a negative 16 is plus 16, and so my answer is 30. Again, don't forget you can press pause if you need more time to copy these things down. Then on the last flap, I want you to write the definition for like terms and the definition of the distributive property. And then there's 2 examples on this one. So the blue is the example, and I underlined the like terms the same way. So 6 and 3 are like terms. They have 1 underline. 15xy squared and negative 10xy squared have a squiggle line. So as I can put those 2 together, they're like terms. Negative 4y squared and plus 9y squared, they can be together as like terms. And 7x and negative 4x are like terms. And then on number 2, I used the distributive property. So I did 3 times 2x and 3 times negative 2. Okay, again, you can pause this if you need more time to copy things down. Let me know if you have any questions. And be sure to bring this and your properties foldable to class on Monday. Thanks, guys.